What is charge? I will go into details of charge of the electron and provide a kind of mathematical framework in order to allow you to understand what charge is and how charge is formed. I think it's critical to really understand what fundamental things are so that we can kind of conceptualize what's going on in the unseen universe of atomic physics. And that's really what the model allows. It allows exploration on the basis of mathematical calculations, and they have implications associated with that. So the electron is a spherical particle. It has a normalized charge of -1. The normalization process, really, one electron actually carries a charge of 1.602 to the -19 coulombs. So large C stands for coulombs. That's a measure of charge, and that is based on a kind of joules of energy. So how many joules of energy does an electron carry? 1.602 to the -19 coulombs. So that's a very, very small number. How do we calculate that number, and how do we refer to that number in terms of the mathematics of electron formation? And I will give you, I guess, a cut down story, and one that hopefully you will be able to link back to other parts of the model at a later date when I provide that kind of detail. So what I'm proposing is that the electron actually has a spherical nature based on a particular radius, and the radius allows you to determine the charge of the electron. Now, the mathematics that I perform to do that is interesting because it's linked to inverse square law, and I'll kind of walk you through the calculations on the following slide. But what I'm providing here as a model is that there is both a positively charged inner surface and a negatively charged outer surface, and the black line in between the two is considered the alpha fine structure constant. When we look at aspects of spectroscopy and in cosmology, there are things called Fraunhofer lines, which refer to electron transitioning from one orbital layer in an atom and another, and it's like a fingerprint for atomic theory. It provides the kind of fingerprint information as to which atoms are present in the universe, in particular stars or galaxies, based on the Fraunhofer line spectral processes that lead to scattering of specific wavelengths. And there's a splitting of the kind of Fraunhofer lines, and I'm proposing that splitting, which has a functional ratio associated with it in terms of 1/137.036, which is the alpha fine structure constant attribute of the universe, and we'll get into it a little bit later, but the alpha fine structure constant has it's a dimensionless number, and it turns up in a number of different places, so it has a useful role to play in how the universe operates, and I'll explore and kind of provide details of that in a later one. But let's just focus here on surface area and the the charge of the electron. So how do we form charge? So with the idea that there's baryonic symmetry, so the formation of matter and antimatter in identical amounts in the universe. So here the idea is we have both the electron and the positron being formed simultaneously from a zero state field, and we'll get to that at a later date as well. And the circumference of the electron and the positron are known as to be determined by 2 pi r. So 2 pi r times 2 pi r gives us 4 pi squared r squared divided by pi, giving us the surface area of 4 pi r squared. So there's a kind of mathematical language and a functionality associated with this model that links to a kind of, you could possibly highlight it as a higher dimensional state, but it relates to dark matter and dark energy, and the model kind of provides details why dark matter contains a particular structure associated with the positron-electron pairing. And that's really why I've got two particles, two circular, or two circles with a circumference of 2 pi r. That's coming from a dark matter process, which I won't allude to here. The surface area in relation to the charge of the electron relates to the diameter of the electron being 4e to the negative 18 of meter, so the radius being 2e to the negative 9 of a meter, and the inversion of that, or the reciprocal of 1 over 2e to the negative 9 equals 5e to the plus 8. So the actual calculation of 4 pi r squared is performed with the 5e to the plus 8 as the radius in this model using inverse square law approach based on the electron being 4e to the negative 18 meters as a diameter. And what we end up finding is that we have a number that's actually double the electron charge. So we end up with, it's close to 3.2 e to the negative 19 coulombs. So that's why I'm kind of outlining that in this spherical particle we call the electron, which is handled as a point particle in the existing kind of standard model of particle physics, because we don't have photon wavelengths small enough to really get down to see the size of the electron. This theoretical electron model based on these calculations gives the electron a particular surface area to charge of a 2-to-1 stoichiometry. So the calculation gives it's 3.18 e to the negative 19c, and you know there's a way of kind of slightly changing the radius so that it equals the right number, but which is double the 1.602e to the negative 19, so 3.2. But that doesn't really matter. What really matters is understanding the implications associated with the model, and the implications are that the electron isn't has a surface, has a volume, it has a property of charge associated with that surface area, and when you understand in principle the functionality of utilizing inverse square law to explore the surface area of the electron, you can see the value and benefit of the model and how it relates to the way that the universe operates which we'll kind of get to. But there's a specific reason why 4e to the negative 18 meter is what the electron diameter is, and that's related to kind of the processes that are happening at a cosmological scale. The surface area to volume ratio is an interesting outcome, because you get 3r to the negative 1, and what really that means is that there's an opportunity for 3 quarks internal within the structure of the proton, with 1 electron on the outside. So there's a 3-in-1 ratio that's established in this functional model, associated with r being at 2e to the negative 9 and its inverse 5e to the plus 8. So those features of the model provide some context for utilizing a surface area of the electron as its charge in Coulombs. So we don't really need to utilize the normalization to give the electron a charge of -1. Now we understand the volume, surface area properties of the electron in terms of a surface area to charge stoichiometry. This understanding is functionally useful because we can explore other functionality associated with the electron in terms of its mass, in terms of other properties associated with the electron as well. So in this way we can kind of see a number of steps involved in forming an electron, and how the universe operates to create electrons. So as I talked a little bit earlier on in another video about the hot Big Bang nucleogenesis, here we're getting into some details associated with cosmology and how cosmology generates electrons and positrons in baryonic symmetry, and the processes involved in that related to pi. And I will kind of refer to the mathematics of pi generation in terms of a kind of differential velocity, but I'll leave it here at the moment in terms of, well, here's a process that appears to be operating to generate electrons, and it gives information in regard to the surface area charge of the electron. So if you're happy with that, we can move forward to the next one.